Hello everybody, my name is Teacher Didi and I will give you a science lesson for today. So today we were asking a question. The question is how battery works. You know, you have a battery, cells, you have electricity inside, and together we will learn how does that work. Are you ready? 3, 2, 1, let's go. Oh, we don't have sound. Okay.
Hi, Doug.
Hi, Waylon.
I have a question for you. How do batteries work?
That's a great question. Before I say anything more, I'm curious. How do you think batteries work?
Okay, kids. So maybe you have an idea how that can work. Maybe you think to the battery we can load. So it's electricity inside. What is electricity? Maybe you can think electricity is energy. So, but what is energy? So the same. So what is electricity? That work is the tiny, very small things inside the matter, the materials, and it's the flow of electrons, very tiny particles, who can be shared between some components and create electricity. But we will see that in more simple way. Okay, let's go.
Well, believe it or not, the answer to this question involves a story about frog legs. Yeah, you heard me right, frog legs. Now, some people prepare and eat the legs of frogs, just like some people eat chicken legs. But one scientist by the last name of
In my country, in France, in my country, we eat frog like that. Hey.
Galvani had a dead frog in his laboratory one day. Not because he was going to eat it, but because he was getting ready to study it. Galvani was really interested in figuring out how people's bodies work, things like muscles and organs. At that time, this was a few hundred years ago, nobody knew yet how exactly people or animals move their muscles. It's hard to see how muscles work from the outside of an animal's body, so it can help to look inside. If an animal dies, scientists can do an operation, like a doctor. This is what's called a dissection. So Galvani had prepared the frog's legs so that he could dissect them and study the muscles. Because he didn't want the frog's legs to rot, he had soaked them in some salt water overnight. He got one out, put it in his dissection pan, and then, as he started to cut it with his scalpel, something amazing happened. The leg suddenly began to twitch and jump. Now, obviously, this was extremely surprising. The frog, after all, was dead. Its legs shouldn't have been able to move. Galvani got so excited. He felt that he had discovered some kind of special power within frogs' muscles. He thought he must be so close to unlocking the secret of how animals move their muscles. Well, news of Galvani's discovery spread fast among all the scientists living at that time. Lots of them were excited to see if they could unlock the secret of how animals move. One of those scientists, a scientist by the last name of Volta, found something even more surprising than Galvani. As Volta tried to repeat Galvani's experiments, he became convinced that the twitching of the frog's leg actually had almost nothing to do with the frog and everything to do with the metal tools that Galvani was using. For example, Volta found out that in one of Galvani's experiments, the frog's leg would only twitch when it was being touched by two different metals. You see, Galvani had used a tool containing the metal copper to hold the frog's leg in place. And Galvani's knife was made of a different kind of metal, a metal containing iron. Volta wondered, what if this special power that Galvani discovered was actually something contained not in frogs' muscles, but in the two different metals? Using no frog legs at all, Volta took two pieces of metal, one of copper and one of iron, just like the metals used in Galvani's experiment. Then he connected a piece of wire to each metal disc. When he touched the two wires together, well, at first nothing happened. But that's when Volta remembered there was one other substance involved in Galvani's frog leg experiments: salt water. Volta added a little disc of cardboard soaked in salt water between the pieces of metal. Suddenly, now when he connected these together, he could feel a slight shock. By stacking up little sandwiches of each metal, separated by discs of saltwater soaked cardboard, Volta discovered that he could increase the strength of the shock. With enough of these little discs all piled up, he could even create a spark. It looked just like he was making a little lightning bolt. What Volta had just invented was the very first battery. In fact, to this day, in some languages, like in French, a battery still goes by the name of Volta's pile. At the time that the battery was invented, Volta and others didn't actually know what kinds of things they'd be useful for. No one had invented anything powered by electricity yet. But over time, as you can guess, that all changed. Today, batteries are one of the most useful inventions ever. Since batteries are a portable form of electricity, they allow us to power things without having to be anywhere near an electrical outlet. Without batteries, we'd have no ability to use smartphones, electric cars, not even flashlights. Today's batteries may look different from the first battery ever invented, although some look incredibly similar on the inside. Either way, all batteries still work the same basic way. They all use Volta's amazing discovery that when you sandwich together two different metals between some kind of liquidy solution, like salt water or acid, electricity is produced. That's all for this week's question. Thanks, Waylon, for asking it. The world is filled with Before you vote on next week's question.
Okay, we'll see if we have bonus, kids. So yes, we have some bonus. So we'll see fun facts, the top 5 of amazing things involving electricity. Okay, let's start. Why are these trees such weird shape? What do you think? What do you think? Look at the picture for clues. What else do you see in the picture? In the tree were trimmed by people. Yes, you see, it's very incredible. So it's like the electricity is a danger for the tree. I don't understand why, because we see in Thailand tree can grow on the electrical lines without problem. So did you notice the power lines? Those carry electricity. People cut off tree branch near power lines so tree don't get zapped like this. Electricity can make spark, which can start fires. Yes, okay. So it's human who cut the tree like that. It's not natural. Oh, wow. See, there is always electricity flowing inside of the power lines. They are like tubes with electricity inside. Sometimes during storms, if the cable breaks, you can see the electricity starting dangerous fire. Take care of that, especially in Thailand, because some transmission lines are very dangerous. Huh? Don't touch them, kids.
Number 4.
Lightning is a form of electricity. You see that? Watch these lightning bolts in slow motion. What shape do you notice? After thinking about that, think about this. If lightning hit the ground, what would it look like? So it's very beautiful. The shape, the shape is beautiful. It looks like a tree a bit, with ramification. Oh, okay, when that touch the ground, the lighter is more important and there is more concentration of the electricity. Check it out, lightning hit the ground in these golf courses. What pattern do you notice in the grass? Oh, wow, so beautiful. So we see line and some, yeah, it look like a tree.
Number 3.
An artist is going to zap a piece of wood with electricity. What do you think it will look like when it's zapped? Never try yourself. So, what do you think? Will be, I think, will be dark, black, and with this ramification we saw before. Oh, what's this piece of wood? Wow, wow, wow! Very beautiful, huh? What as this piece of wood is zapped with electricity at its two corners. The electricity sets the wood on fire and it spread. Check out the pattern that it makes. Look familiar? Yes, it's the same pattern we saw before. Wow, 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 it looks like a tree. Incredible. It's beautiful.
Number 2.
Okay, maybe you've heard of electricity hills before, and you may know that electricity can light up a light bulb. Here is strange question: could you get an electric eel to light up a light bulb? How? Yeah, maybe if you put the bulb like that on the body of the eel, but it's dangerous. You maybe have accident. A scientist put a fake human arm in a fish tank with an electricity eel. The fake arm has a lot of light bulb inside. Watch what happens as the eel jump onto the arm. Yeah, because it's electric eel, so that creates electricity.
And now the last one.
Electricity makes cool branching pattern when it hits things. Could you invent something for lighting to hit? Ain't electricity like to hit metal? It'd be dangerous to really do this, but you can pretend. People have made metal sweet for fun. That big round machine make electricity and it zaps the metal sweet. Never do this, it's very dangerous. People are trained scientists. Yes, because the electricity is very, very important, and if you don't have this combination, this protection, you could simply die. A band called Heart Attack. Oh. A band called Heart Attack sometimes wear metal sweets. Imagine playing guitar while being struck by lightning. It doesn't hurt them, but only because the sweets are special, built to be safe. Very, very impressive. Okay, kids, I think it's the end, huh? Yes, it's the end of the lesson. So thanks for watching and see you next time. Bye
For the next
bye.
episode, I reach